You guys are good.
So I'm Morgan.
I'm Hillary.
And I'm Ryan.
And we did calculus in theater, and the reason why we chose that is, well,
There you go.
we're all in theater, and so my favorite show is Aladdin.
And mine is Aida.
Just
Despite the t-shirt.
We wanted to show the diversity of the shows we've been in. So I act in theater, Morgan does crew, mostly like the soundboard side of things, and Ryan plays various instruments in the pit.
He just plays like all of them, and it's great.
Yeah. So some concepts that we're going to cover today in our presentation are integrals, and then to find average amounts. We're going to find average amounts of decibels, people waiting in line, and the amount of shows over a certain amount of years. We're also going to use arc length to compute the area of the stage, and some trigonometry to try and find the best seat in the house. So Morgan was able to attend the choir concert on May 20th, and so we took some different information from that. So we did the decibels throughout the entire concert. We did decibels during the final song, Hey Jude, and the number of people waiting on the right side of the entrance to the PAC.
Alright, so decibels throughout the entire concert. First, a little kind of context behind what a decibel is. It's basically a unit or measurement of sound in how loud I am, the kind of how much sound waves I'm producing right now. There's a level in which the decibel count goes, and that's from 0 to 196. And at 196, the decibel level gets so high that there's no medium for it to go through, so like air or water, that just kind of dissipates and it becomes a shock wave instead, and we'll cover that later. So there's a unit of measurement. So like this, me whispering is about 50, but not really because it's kind of a really loud whisper. And this is about 60. And this is about 70. It's kind of out of my comfort zone. So basically, we took in intervals of about 10 minutes from 7 p.m. to 8:45, or 5-minute intervals, I should say. We took decibels, and that is the function we got. It was a quartic. So the amount of decibels for the entire show was about 5,062.311 thousandths decibels, and that's quite a lot in terms of decibels. But if you take the graph and you find the average amount, it's about 48. So kind of a loud whisper, normal voice.
Do you want to explain how you got the decibels, measured that?
Yes, that'd probably be a good idea. So I downloaded an app on my computer, and it's basically a decibel measurer. So you've got like a microphone on your computer, right? And it would have a graph and measure like anybody talking or whispering. And I was up in the sound booth, so the decibel count was a little bit off because I was farther away and not in the audience, but it was still accurate for its purposes in the graph. Here's the graph itself. So obviously, you know, there's a formula to concerts. You open with a really great song and everybody's like, woo! And then it goes down and like sad, slow songs. And then you end with a woo! And that was Hey Jude, because it was a Beatles concert. So obviously, you know, you just gotta go with that. Context of the graph. So like I said earlier, the entire show was about 5,000 decibels. Now, the loudest sound known to man is about 310 decibels. And that was a volcano explosion on the island of Krakatoa in Indonesia. So this entire concert was about 17 times that amount. But it exploded in August 1883. It reached the sound limit, which is 196. So there was a shock wave, and it circled around the Earth about 4 times. So it was heard 3,000 miles away, and about 2,000 miles away, it ruptured the eardrums of sailors. So that's really, really loud. And then it did tear the island apart. It's like kind of non-existent anymore, but This is a video of like a smaller volcano, but it does demonstrate the shock wave. That was in Tav River volcano. That was Papua New Guinea in August 2014. So like, if you want to go on vacation in like the volcano island places, don't go in August. Bad idea. Okay, let's see. You guys hear it? Yeah.
The shock's coming.
So the captain does warn us. So yeah, that is a demonstration of the shock wave. You can see the clouds just kind of dissipate from the force of the sound waves because it was over 196 decibels, at least in the center of the volcano. Here's
And another problem that we did with including decibels was the decibels just during the last song, which was Hey Jude. And this is our function for amount of decibels over the time, which was about 4 minutes. And the total amount of decibels through the entire song was 245. And then if you divide that by 4, the amount of decibels per each minute is about 61.322, which is about the sound of the person talking. And this is a graph of the decibels over time. And then this is about the very last part of the song.
where everybody's like na 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 na, and the drums are going crazy. Yes.
Okay. And then another graph that we did while we were at the Carter concert was how many people went in. And Morgan kept track of the right door of the BSC. This is a function for how many people went in. And we did intervals of 5 minutes for how many people went in. And the graph of best fit was a quartic, but it gave us like a really high number when we took the integral from 0 to 40 minutes. And it gave us like about 1,500 people, and that's way too much. And then the average amount of people per minute is about 39, which is still a lot because I think the PAC can only hold like 600 people. And this is our graph for amount of people waiting in line.
So then we wanted to incorporate the stage a little bit, and so a little thing that you need to know, like for this presentation, is this. I drew in this red line right here, and this is called the apron of the stage. So there's a curve right here, and we measured it. So like underneath the apron of the stage is where the pit hangs out and plays during songs, and that can actually be removed. And so each one of those blocks is about the same width, and so we measured one of those widths and multiplied it by how many there were, and there's somewhere between like 30 and 35 of them. And so that's how we came up with 44.625 feet. And we also like measured with a tape measure, but we wanted to do the individual rectangles because we didn't have a long enough tape measure that was 44 feet. So we had to like pick up the tape measure and move it, so we thought it'd be more accurate if we measured the individual boxes. And so we wanted to find the arc length of the edge of the stage right here. And so Ryan and I went out there, and at every foot we measured from this red line to the curve in inches, and then converted it to feet. And came up with this function by plugging it into our calculators. And again, it was a quartic one. And then the length of the arc that's the general formula, and we plugged in S of t for or S of x for the stage, and got the length of that arc is about 44.843 feet. So then this is what it looked like on our calculator, and each one of these boxes represents each foot that we took a measurement in. And the x-axis is 0 to 44, and the y was at most we had 1.771 feet. So then we wanted to do the total area of the stage, and so another little theater thing that you need to know is, so this is like the big curtain that you guys see when you typically go into the PIC, it's that red one. That's called the proscenium, and then each curtain after that is considered a leg, so that's a leg, that's a leg, and so typically most of the acting that's going to happen, like for our high school shows, happen from the third leg back forward, and so that's how we decided to calculate the area of the stage. Like, we didn't go all the way to the back wall, like towards the scene shop, because nobody's really going to be there and there's typically curtains, and we just don't use that because it's hard to see that far and it's hard for people to project out into the audience for people to hear their voices. And so again, we had that curve that was on the front of the stage, it's just not shown in that picture, and so we were able to integrate from 0 to that 44.625 feet again, and that gave us area under the curve of 55.217 feet squared. And then amongst the rest of the stage, we just used simple geometry to compute rectangles and trapezoids to find the total area of the stage, which ended up being 1,443.253 feet squared.
Okay, and then the reason why we did areas of the stage is because we wanted to see like how many people could do our warm-up song, which is Beyonce. And we did we had a rough estimate with Hillary, like just doing like some moves, like how far forward, how far back, and then left and right. And it was about 9 feet, and then 8 3/4 of the zone. And then if like we had no one overlapping each other's boxes, it would be about 42 people. But realistically, people are going to overlap and be closer together, so it would probably be around like 130.
Oh wait, shoot. Go back to the. Is the video play, Ryan?
Yeah, it should. We can just watch like a couple seconds.
So like as you can see, the people are really close together, and like we're gonna go to the right and to the left. So if like Morgan and I are next to each other, and she has her like 9 feet, I'm gonna go into some of her feet. So that's how we like approximated about 130 people.
It really is a good workout.
Yeah. If you fast forward, you can show like where we overlap.
10 out of 10 do recommend.
Yeah. So this is where we go forward and backwards, and then we also go right and left.
But yeah, that's our one.
Okay, and then another thing that we decided to do was like about how many Broadway shows happened since from 1970 to 2010. And the reason why we chose those years is because like copyright is like usually done by 2010 or like whatever, like last like 5 years. So we figured those numbers would be accurate. Anyway, we took the we entered the data from Wikipedia of how many shows for each year, and then this is our function we got. And there's about 952 shows per year, and we wanted to compare it to how many there actually were, and it was like 987. And then if we use the average number from our integral from 0 to 40, it would be about 23.809 shows per year. And then this is a graph of how many shows there were. Like it took a dip towards the 90s and it peaked towards the 2010s.
Alright, so our last problem for today was the best seat in the house problem. And that one Ryan found as a PDF on the internet. Now what these people had done is like, it's from a math book really, and so here's a picture of the problem they had. And so what they were trying to figure out is this data right here. They wanted to figure out what would be the best maximized view of that depending on where you sit in the Rose Theater. Obviously, John Travolta had no idea what he was doing because he sat pretty close to the front. So what we were trying to do was find the data through angle measurements and data. We thought it would be fun to try and replicate this problem, but with our very own theater, the PAC. So we did take a bunch of measurements, and so using the law of cosines, well, actually we used the inverse law of cosines. So right here, this formula, we modified it so that we would be finding the angle theta. So we found C by dropping a tape measure from the very top. There's like kind of a ceiling and a walkway where you can walk on. So we dropped a tape measure from there and we found C. And so we needed to find A and B, and we did that through a lot of measurements, and that's how we got them here. If you have any questions, you can ask like after class, because it does take a while to explain. But many calculations later,